Hi, Robin here. This is 1.4.3 of the Boolean Algebra section of the OCR A-Level Computer Science. Specifically though, we're going to be looking at the rising edge D-type flip-flop. A flip-flop is a circuit that is able to store one bit of data. It does this by constantly having electricity in it. If there's no electricity within it, it doesn't work. That's why on the truth table, if you've got A and B having a zero value, we've crossed it out. It's irrelevant, it doesn't work. So assuming there is always electricity within the circuit, what will therefore happen is that depending on whether it's A or B or both of them will determine whether the P value or the Q value is shown. And as you can see from the table, they are never on at the same time. In other words, what's then happening is that the circuit is flipping between the P and the Q, hence the name, and it goes between the two states of it. So this is a really useful circuit. Like I said, it's a form of volatile memory due to the requirement of having electricity present, and it's often used in things like static RAM and registers, or certainly different forms of it are. We specifically need to look at the rising edge D-type flip-flop for the OCR level spec. So by rising edge, what we're talking about there is the clock cycle. So as the clock cycle is being carried out, and that's, as we know with the fetch, decode, execute cycle, that's keeping everything in sync, we're using this as a mechanism to change the value, and therefore we store that part of data, the value, for the period of time that that clock cycle is within its cycle. In other words, it's going to be appropriate for whatever instructions are being carried out at that time. So when we're doing this, we would use a timing diagram like so to sort of visualize what's going on. But what we've actually got is a value between 0 and 1. Electricity doesn't just jump from 0 to 1, it actually increases. So that period of time when it's increasing here, we call the rising edge. It would go along at a value of 1, and then it would then come back down again to 0, and that is the completion then of an entire clock cycle. As you can see again, it would then go up again for a second time. We're interested in this rising edge part, and that's what determines kind of the change in the value. So this is what a full rising edge D-type flip-flop circuit looks like. You can see it's made up of two parts. The reason for that is that the first part is called the master, and that determines what happens to the slave part, the second part, this part here. And that gives us this ability to hold and retain the value over a longer period of time across multiple cycles if needed. We're going to look at an example exam question for a rising edge D-type flip-flop. What we're going to look at is how the data value going in between 0 and 1 will relate to the clock cycle, and therefore will give us a value of Q, Q representing where data is stored or where it's not stored. So if at 1, it's then stored. This is a rising edge D-type flip-flop. What the rising edge is referring to is the rising edge of the clock. What we've got then is the clock signal, so it starts at 0 and will rise to 1. In other words, we're interested in this part of the cycle. It goes along at 1, will then drop back down to 0, go along at 0, and then will rise again at this point. In other words, we're not actually interested in this part of the clock cycle at all. We don't use that. I'm going to go along and I'm just going to find all of my rising edges. So you can see it's rising again. It's going to rise again here, rise again here, rise again here, and that's our last one that's shown on the paper. What we're then going to do is we're looking above that rising edge to see what the data value is at that point. As you can see, the data value has risen to 1, and that's what we're then going to use. So in other words, we could actually go along and do this and show that at this point it's come down and it's going back up again, so it's still up. Again here, it's actually still up. Here, it's gone down. Here, it's gone up again. And then here, it's still up. What we need to do is show what that would look like in our Q line. So in other words, all we're going to do is we're going to look at the Q and we're going to look and see where that mark is that I've made effectively. So we've got is going up here, so I'm going to represent that and go across and make that go up. Then we're going to move across to the next point. That's still up, so therefore I'm going to draw along to that point. You can see I'm still in line with it. I'm looking across to the next one, it's still up, and therefore again, I'm going to draw that line. Then we come along to here, and it's actually gone down now. So I'm going to come along to here, to that point, and then I'm going to go down to represent that. What we've actually effectively got then shown is that data was held for 1, 2, 3 clock cycles. I come along to my next one, so I'm going to draw the line along here like so. It's up, so I'm going to bring this one up. We come along, you can see this one is still up, so therefore we're going to come along to here, and then we'll just continue that because we've not got clock cycle bringing it down, so that will just continue off the page. So in other words, we've got a period of time here where we're storing a data value of 1, then we have a value of 0 stored, and then we then store again a value of 1. Okay, let's look at the circuit for a rising edge D-type flip-flop in action. Okay, so what you can see here is a rising edge D-type flip-flop. As you can see, it's an electrical circuit that's made up of NOT gates and AND gates, and hopefully as you can see that we've got live wires that are on, and then we've got some that aren't currently having electricity in them. And as you can see that there's effectively a pattern to this now, that the electricity is going on and off throughout the circuit. That's being controlled by this bottom left-hand corner, which is the clock. So as our clock cycle goes on and off, therefore, so does the electricity. But the thing to notice with this is we have two parts to the circuit. We have the master section and then the slave section. In other words, what's happening is the electricity from the clock is going into the master section, and only if the master section allows it does the slave section then change. The slave section, therefore, keeps currently our Q value as off. If we want the Q value to change to 1, what we need to therefore do is change the input at the top left-hand corner to do so. So I'm just going to do that for you now. And as you can see, it's now changed. What actually happened there, though, was as the D value, the input, came on, it didn't change the Q value immediately. It actually waited until the clock cycle changed and there was therefore ready for it. This is why it's called a rising edge D-type flip-flop, because the change will only happen on the rising edge of the clock. What I want you to notice now is as I turn the input off, watch the Q value in the top right hand corner, and there'll be a slight delay between me turning it off and when it actually happens. Okay, so I'm just going to turn it off now, and then it changed. I'm going to turn it back on again now, and then there's the delay and it's changed. The reason for that, like I said, is because the rising edge is waiting for the clock's rising edge before it will change throughout the circuit. Okay, so what I want to do is show you the oscilloscope. The oscilloscope shows the electricity passing through our circuit. You can see at the bottom we have the clock cycle. This is what's drawn when we do this on paper. We have the Q value, that's the output given. That's the one that we have to create ourselves when we're ever given these in exam questions. And then we have the user input, that's our D value. At the moment, there's not a lot to see because there's been no changes going on. What I'm going to do is just make some changes to the input value. So I'm going to turn it off. I'm going to turn it on. I'm going to turn it off. And I'm going to turn it on again. You can see now that that is reflected in here. Our rising edge has caused the user input to change the Q value, and therefore as the input's gone on or off, depending on where the rising edge was, that's caused that D value to change as a result of it. And that's what we're doing when we do it on paper. Well, thank you for watching. I really appreciate it and really hope you've learned something from that. Do please like and subscribe. It really does help me to help others, and I'll hopefully see you again. Thanks a lot.